For centuries, we have looked at the night sky and wondered, what lies beyond our cosmic neighborhood? Is the solar system just a tiny island in a vast cosmic ocean? What strange worlds, unseen forces, and unknown mysteries await us beyond the reach of our sun? Our solar system is our home in space, but it is far from the only place where wonders exist. Beyond Neptune and Pluto, the sun's influence begins to fade. At the outer edges of our system, a vast cloud of icy objects, the Oort cloud, marks the boundary between our world and the unknown. And beyond that, interstellar space, a region filled with radiation, rogue planets, and distant stars. For the first time in human history, we are beginning to explore beyond our solar neighborhood. What have we discovered so far? And what secrets still remain hidden in the endless darkness? In this documentary, we will embark on a journey to explore the history of our quest to understand what lies beyond the solar system, examine the strange and mysterious objects that exist in interstellar space, investigate how humanity is pushing the boundaries of exploration with spacecraft like Voyager and New Horizons, and ask the ultimate question: what is waiting for us beyond our own galaxy? What lies beyond the edge of the solar system? It's time to find out. For most of human history, the stars beyond our solar system remained unreachable, tiny points of light in the vast darkness. We could only speculate about what lay beyond our sun's influence. But everything changed with the rise of modern astronomy and space exploration. Keycap won the early theories, a universe beyond the sun. Long before telescopes, ancient civilizations already questioned what lay beyond the planets they could see with the naked eye. The ancient Greeks, including philosophers like Aristotle and Ptolemy, believed that the stars were fixed in a celestial sphere, a cosmic boundary that enclosed our solar system. Copernicus and Galileo shattered this idea in the 16th and 17th centuries, proving that Earth was not the center of the universe and that the sun was just one of many stars. Isaac Newton's theory of gravity suggested that the same forces governing planets also extended to the stars, hinting that our solar system was part of a much larger cosmic structure. But these were only theories. To truly explore beyond the solar system, we needed more than just ideas. We needed technology. Keycap to the birth of interstellar astronomy. The 19th and 20th centuries brought massive breakthroughs that allowed us to peer beyond the boundaries of our own solar system. 1838, Friedrich Bessel measured the first accurate distance to another star, proving that the stars were not fixed in a celestial sphere, but were scattered across a vast universe. 1901, scientists began discovering exoplanet-like objects around distant stars, long before they had the tools to confirm their existence. 1950s to 1970s, astronomers theorized the existence of the Oort cloud, a massive collection of icy objects marking the true outer boundary of our solar system. Still, no human-made object had ever ventured beyond the solar system. That would take the next great leap, the space age. Keycap 3, the space age, humanity's first attempts to leave the solar system. The mid-20th century saw the birth of space exploration, and with it, the first attempts to send probes beyond our planetary system. 1972, NASA launched Pioneer 10, the first spacecraft to head toward interstellar space. 1973, Pioneer 11 followed, capturing stunning images of Jupiter and Saturn before heading into deep space. 1977, the launch of Voyager 1 and Voyager 2, the most famous interstellar probes, forever changed our understanding of the outer solar system. Voyager 1 and 2 were not just planetary explorers. They were designed to leave the solar system entirely. 1990, Voyager 1 took the famous pale blue dot photo, showing Earth as a tiny speck in the vastness of space. 2012, Voyager 1 became the first human-made object to officially enter interstellar space, followed by Voyager 2 in 2018. For the first time, humanity had sent something beyond the solar system, into the unknown. Keycap for the true boundaries of the solar system. Most people think the solar system ends at Pluto, but in reality, our star's influence extends far beyond that. The Kuiper Belt, 30 to 50 Australian dollars from the Sun, a region filled with icy objects and dwarf planets like Pluto, Makemake, and Eris. The heliosphere, 120 Australian dollars, the bubble of solar wind that surrounds and protects the solar system. The Oort cloud, 5,000 to 100,000 Australian dollars, a massive, hypothetical shell of icy comets marking the true outer edge of our system. It takes Voyager 1 nearly 17,000 years to fully cross the Oort cloud and reach the interstellar medium, proving just how vast our own backyard in space really is. Beyond this, there is nothing but the void until we reach the stars. Summary of the historical background section. Heavy checkmark: ancient civilizations believed in a cosmic boundary around the stars. Heavy checkmark: astronomers in the 19th and 20th centuries proved that space extends far beyond the sun's influence. Heavy checkmark: the space age sent the first probes toward interstellar space, with Voyager 1 officially leaving the solar system in 2012. Heavy checkmark: the true boundaries of our system extend far beyond Pluto, reaching into the Oort cloud. Beyond the solar system, there are no planets, no moons, no familiar landmarks, only the endless void of interstellar space. But this void is not empty. It is filled with cosmic phenomena that challenge our understanding of the universe. What truly exists beyond the sun's influence? Let's explore the strange and mysterious objects that inhabit interstellar space. Keycap 1. The interstellar medium, the substance of space itself. Despite appearing empty, interstellar space is not a complete vacuum. It is filled with a thin, ghostly substance known as the interstellar medium. This medium is composed of hydrogen and helium gas, cosmic dust, and traces of heavier elements. It is so diffuse that a single cubic centimeter contains fewer atoms than an earthbound laboratory vacuum. However, these tiny particles play a critical role in star formation, as they slowly accumulate into dense clouds. The interstellar medium is the birthplace of stars and planets, a cosmic ocean from which new solar systems emerge. Keycap 2. Rogue planets, worlds without a sun. Not all planets orbit stars. Some are wanderers, rogue planets, ejected from their home systems and doomed to drift through interstellar space forever. Scientists estimate that for every star in a galaxy, there could be at least one rogue planet, meaning trillions of such worlds may exist. Some are cold and dead, frozen solid without the warmth of a sun. Others may have thick atmospheres or subsurface oceans, retaining enough heat from their formation to harbor alien life. Could some of these lost worlds still sustain life, even without a sun? Keycap 3. The closest star systems, our nearest neighbors. Once we leave the solar system, the nearest stars to us are in the Alpha Centauri system, just 4.24 light-years away. Alpha Centauri A and B, a pair of sun-like stars locked in a binary orbit. Proxima Centauri, a red dwarf that is the closest star to Earth and home to Proxima b, an exoplanet in the habitable zone. Could Proxima b be the closest Earth-like world? And what about the countless other star systems beyond? Keycap 4. Exoplanets, strange worlds orbiting alien suns. Since the 1990s, astronomers have discovered thousands of exoplanets, planets orbiting stars beyond our solar system. Some of these planets defy everything we thought we knew about planetary science. Super-Earths, planets larger than Earth but smaller than Neptune, possibly covered in vast oceans or endless rocky landscapes. Hot Jupiters, gas giants that orbit dangerously close to their stars, scorched by intense radiation. Puffy planets, worlds so large yet so light they seem like giant balloons of gas. Hell planets, planets like K2-141b, where oceans boil away and rains of molten rock fall from the sky. If these planets exist so close to us, what bizarre worlds might lie even deeper in space? Keycap 5. The interstellar highways, cosmic pathways between the stars. Despite the vast distances between stars, There are natural pathways in space that could one day be used for travel. Galactic currents. Gravitational forces create streams of matter and energy flowing between stars. Interstellar winds. Particles from stellar explosions form vast, invisible currents pushing objects between star systems. Wormholes, theoretical if they exist, these shortcuts could link distant parts of the universe almost instantly. If humanity ever travels beyond the solar system, could we use these cosmic highways to shorten the journey? Keycap's 6 black holes, the cosmic abyss. Among the most terrifying objects in interstellar space are black holes, regions where gravity is so intense that not even light can escape. Some black holes form from the collapse of massive stars, creating stellar black holes. Others, like the one at the center of our galaxy, are supermassive monsters millions of times heavier than the Sun. If a spacecraft ventured too close, it would be stretched into oblivion by spaghettification, a process where gravity pulls objects apart atom by atom. Could there be entire civilizations orbiting black holes, using them as energy sources? Keycap 7, the ultimate question. Are we alone? For centuries, humans have looked to the stars and wondered, is there life beyond Earth? Some scientists believe life could be common in the universe, existing on rogue planets, exoplanets, or even in the vast interstellar medium itself. Others argue that intelligent civilizations may be incredibly rare or even extinct due to cosmic catastrophes. The Fermi paradox asks, if the universe is so vast, why haven't we found any evidence of alien life yet? What if the answer has been out there all along, waiting for us to find it? Summary of the main section. Heavy checkmark interstellar space is filled with cosmic dust, rogue planets, and exoplanets orbiting alien suns. Heavy checkmark, the nearest star system, Alpha Centauri, may hold an Earth-like world. Heavy checkmark, there are invisible cosmic highways that could one day be used for interstellar travel. Heavy checkmark, black holes and other mysterious objects pose both dangers and scientific opportunities. Heavy checkmark, the search for extraterrestrial life remains one of the biggest unanswered questions in science. For now, interstellar space remains beyond our reach. The distances are too vast, and our technology is too primitive. But will this always be the case? Could we one day send spacecraft, or even humans, beyond the solar system? Humanity has always been driven by exploration. From the first steps on the moon to robotic missions on Mars, each step has brought us closer to venturing beyond our own stellar backyard. In this chapter, we explore the theories, technologies, and challenges of interstellar travel, and what the future might hold for humanity among the stars. Keycap 1. The challenges of interstellar travel. Traveling beyond the solar system isn't just difficult. It's nearly impossible with current technology. Distance. The closest star, Proxima Centauri, is 4.24 light-years away. With today's spacecraft, it would take thousands of years to get there. Fuel and energy. Conventional rockets would need far more fuel than they can carry for such long journeys. Radiation and isolation. A human crew traveling for decades or centuries would face deadly cosmic radiation, psychological challenges, and limited resources. So, how do we overcome these challenges? Keycap 2. Future spacecraft. How we might travel beyond the solar system. Scientists and engineers are working on revolutionary propulsion systems that could one day allow us to reach other stars. A. Nuclear and fusion propulsion. Nuclear-powered rockets could be 10 times faster than chemical rockets, reducing interstellar travel time. Fusion propulsion, using the same energy that powers the sun, could push spacecraft to a fraction of the speed of light. B. Solar sails, riding the power of light. Light sails, like Breakthrough Starshot, could use lasers from Earth to push tiny probes to nearby stars within decades. These spacecraft could travel at 20% the speed of light, reaching Alpha Centauri in just 20 years. C. Antimatter engines, the ultimate power source. If we could harness antimatter, a spacecraft could reach near light speed, making interstellar travel feasible. However, antimatter is difficult to create and store, making this technology purely theoretical for now. If we ever hope to leave our solar neighborhood, these new technologies will be the key. Keycap 3-generation ships, traveling across centuries. If fast travel isn't possible, humanity may have to consider generation ships. Massive self-sustaining spacecraft where multiple generations live and die during the journey. These ships would be miniature, self-sustaining worlds, complete with artificial gravity, farms, and ecosystems. Crews would live their entire lives aboard, passing knowledge to their descendants, who would eventually reach the destination. The biggest challenge? Social stability. Can humans survive centuries of isolation in deep space? Would future generations be willing to sacrifice their lives for a destination they will never see? Keycap 4 colonizing exoplanets, humanity's next home? Even if we reach another star, we still face a major challenge: finding a habitable world. The best candidate? Proxima b, an Earth-sized exoplanet in the habitable zone of Proxima Centauri. Other possibilities include super-Earths or even terraforming Mars first as a stepping stone. If a planet is not habitable, future colonists may have to live in domed cities or floating habitats orbiting distant stars. Could humanity spread across the galaxy, becoming an interstellar species? Keycap 5 the Fermi paradox. Where is everyone? If interstellar travel is possible, then where are all the other civilizations? The Fermi paradox asks, if the universe is full of stars and planets, why haven't we found any evidence of extraterrestrial life? Possible answers include, we are the first intelligent civilization. Life is incredibly rare. Advanced aliens exist, but they are avoiding us. Civilizations self-destruct before reaching interstellar travel. Are we truly alone, or is the universe teeming with life we simply haven't discovered yet? Keycap 6 the ultimate future, a galactic civilization. If humanity survives long enough, we could one day expand across the entire galaxy. Dyson spheres, massive structures built around stars to capture all their energy. Artificial intelligence, AI-driven spacecraft exploring the universe without humans. Post-human evolution, will we evolve into a new form of life better suited for space? The road to the stars is long, but if we succeed, we may one day call the entire galaxy our home. Summary of the future of humanity beyond the solar system. Heavy checkmark: interstellar travel is difficult but not impossible. New propulsion technologies may one day make it a reality. Heavy checkmark: generation ships and self-sustaining space habitats could help us survive long journeys. Heavy checkmark: finding a habitable exoplanet is crucial for colonization. Heavy checkmark: the Fermi paradox remains a mystery. If life exists, why haven't we found it? Heavy checkmark: in the distant future, humanity could spread across the galaxy, becoming a truly interstellar species. For now, we remain bound to our solar system. Our home is a single planet, orbiting a single star in a single galaxy. But this is just the beginning of our story. Humanity is at a crossroads. We have sent spacecraft beyond our solar system, but they are still only in the earliest stages of interstellar travel. We have found thousands of exoplanets, but we have yet to set foot on any of them. We continue to search for extraterrestrial life, but the universe remains silent. Yet, we are still learning, still pushing forward, still reaching for the stars. Keycap 1. What we've discovered so far. In this journey beyond the solar system, we have explored. Heavy checkmark: the boundaries of our own system, including the Oort cloud and interstellar space. Heavy checkmark: the mysteries of the interstellar medium, rogue planets, and cosmic highways. Heavy checkmark: the incredible variety of exoplanets, some of which could be habitable. Heavy checkmark: the challenges of interstellar travel and the technologies that might one day take us beyond our home system. Heavy checkmark: the great question of extraterrestrial life and the paradox of why we haven't found it. Each of these discoveries brings us closer to understanding our place in the universe. Keycap 2. The future of exploration, our next steps. What happens next? We continue to search for habitable exoplanets, and perhaps even send robotic probes to study them. We develop new propulsion technologies, bringing interstellar travel closer to reality. We keep listening for signals from other civilizations, hoping to answer the question, are we alone? And one day, perhaps in the distant future, humanity itself will leave Earth behind, setting foot on a new world among the stars. The universe is vast, mysterious, and full of wonders waiting to be discovered. The only question is, how far will we go? Keycap 3, a final thought. The universe awaits. Humanity has always looked to the stars, from the first cave paintings of constellations to the telescopes that peer across the cosmos today. We are only at the beginning of our journey. The universe is a frontier beyond imagination. Our fate is in our hands. We can choose to remain on Earth, or we can become explorers of the cosmos. The stars are calling. Will we answer? Final summary. The destiny of humanity among the stars. Heavy checkmark, the solar system is only the beginning. We are part of something much bigger. Heavy checkmark, interstellar space is a vast, mysterious place filled with rogue planets, exoplanets, and cosmic wonders. Heavy checkmark, we are developing the technology to one day explore beyond our solar system. Heavy checkmark, the search for alien life continues, but for now, the universe remains silent. Heavy checkmark, our future lies among the stars, if we dare to take the next step.